Ladies and gentlemen, today I am embracing one of my favorite topics in cybersecurity, and the topic is malware analysis. TryHackMe has recently launched a room that talks about this malware analysis. Actually, it's a beginner level room. Are you a person with bunch of curiosity towards malware analysis, but not sure from where to begin and how to begin? Then, mate, this video is for you. I'm going to explain what are the things you need to ensure before beginning the malware analysis and how you can begin this malware analysis journey. So, without further ado, let me begin. Okay, now we are in the room. Intro to malware analysis. What to do when you run into a suspected malware. So they are going to explain that. So this is the one line description about this room. And they gave their machine. We are going to access this machine to deal with some real-time samples, and we can just click the split view to open and access that machine, and make sure you have to be connected on TryHackMe's VPN. And there are 8 topics, including introduction and the conclusion. The first one is malware analysis and techniques of malware analysis, basic static analysis, the PE file header, basic dynamic analysis, anti-analysis techniques. So these are the topics that we are going to go through. Without further ado, let's begin. Introduction. Every once in a while, when you are working as a SOC analyst, you will come across the content, file, or traffic that seems to be suspicious. And you will have to decide whether the content is malicious or not. Yeah, if you are in a cybersecurity field, then you must have gone through this kind of situation before, encountering a file, but not deciding whether the file is benign or malicious, not able to decide. So those kind of situation, if you ever faced, then please carefully watch this. It is normal to feel confused with all the mixed signals that such content provides. This becomes a little overwhelming for somebody who is just starting in cybersecurity. Yes, it is. And it is common to begin self guessing oneself. Knowing what steps to take to resolve such a scenario is helpful. This room will lay down some steps to help you make the initial conclusion about the particular suspicious file. Notably, in this room, you will learn. So, here you can see the index, the agenda of this room. What is malware? How to start analyzing a malware, static and dynamic malware analysis. And if you are getting into malware analysis, then you have to understand the processes in the malware analysis. So the static and dynamic are two processes in malware analysis. So they are going to explain at high level about this and resources to help you analyze malware. So here here is the introduction, and without further ado, let's begin now. And malware analysis, the topic. So first of all, they gave the definition. What is malware? The word malware is derived from the term malicious software. So they added these words and they created a new word called malware by taking some letters from each word. Therefore, any software that has a malicious purpose can be considered malware. A software that is purposefully made for some nefarious activities, for nefarious purposes, then it's a malware. Malware, when you heard the term malware, you can think about a specific software, but it is not like that. Malware, malwares are defined based on their behavior. Based on the behavior only, it is being defined. For example, let's say the remote access Trojan, ransomwares, backdoors, adware. So these are the types of malwares, and obviously it is being defined based on its behavior. So that's what they gave here. Malware is further classified into different categories based on its behavior. However, we will not go into the detail of those in this room. So I gave few examples. So even we can create a separate room for these different types of malwares, but that is for a different video. So here we will ponder the steps we will take if we suspect that we found a malware in a machine. All right. The purpose behind malware analysis. So here they gave the each and every sections of cyber defense and how the malware analysis topic is being one among the topics that they handle. So let's see. Malware analysis is an important skill to have. As a quick overview, malware analysis is performed by the following people in the cybersecurity industry. If you are in a security operations team, then analyzing malware to write detections for malicious activity in their network. Then obviously you must have encountered this, witnessing some suspicious samples, malwares in your network traffic, and you have to find a way to restrict those kind of traffic, those kind of files from future. All right. And the next one is incident responder. Are you in an incident response team? Then you must have analyzed the malware to determine what damage has been done to an environment to remediate and revert the damage. So it's all about responding to an incident after it has happened. And the threat hunting, the team to analyze malware to identify its IOCs, which they use to hunt for malware in a network. For example, if you are coming across a sample that is confirmed to be a malware, then your job is to create or fetch the IOCs from that sample and use those IOCs in your network security solutions, so that you will be able to prevent those uh, the samples from infecting your systems and network. And the malware researchers in security product vendor teams. For example, if you let's consider the vendors like antivirus vendors and other security vendors. They should be, I mean, there should be some malware researchers in, in each their organization. So what they will do, they will analyze these kind of new malwares, and they try to add the detections for them in their security products. They will try to analyze the behavior of the malware. Once they gone through each and everything related to the malware, they will collect all those details, and they use those details in their security products for future prevention. And the threat research teams in OS vendors like Microsoft and Google do analyze malware to discover the vulnerabilities exploited. In case if the malware is exploiting any vulnerability, then they will find those vulnerabilities that is being exploited, and they try to patch those vulnerability in their products. So that is the role of threat researchers. All right. So if you see any field, any section in the cyber defense, malware analysis is an integral part. So it is very inevitable topic. So let's begin. Let's try to read further. Overall, it seems like many different people do malware analysis for many compelling reasons. Yes, they are. And before we begin, we need to make sure the given advisories. So let's see what it is. Please note that malware is like a weapon because it can produce great harm if not handled with care. For this reason, always take the following precautions while analyzing the malware. So they gave some precautionary measures. You have to make sure each and every steps that they gave here before analyzing a critical sample. Never analyze malware or suspected malware on a machine that does not have sole purpose of analyzing the malware. So the simple, if you are trying to analyze a malware, then do not use the machine that you are mainly using. Do not analyze the malware on your base machine, your main machine, where you stored all those confidential data. Always do use some isolated environment. It might be VM, or it might be some cloud instance or whatever. Do use some isolated environment. So when not analyzing or moving malware samples around to different locations, always keep them in password protected zip or rar or other archives, so that we can avoid accidental detonation. Even I have done some couple of malware analysis videos before in my channel. In every video you might have seen, I usually kept those malwares in a password protected zip. So that is another advisory. Only extract the malware from this password protected archive inside the isolated environment. Then only you need to start the analysis. Create an isolated VM specifically for malware analysis, which has the capability of being reverted to a clean slate once you are done. Ensure that all the internet connections are closed or least monitored. Let me explain this. If you are using virtual machine, then you have to ensure those network connectivities are shut, or the restricted network access. You need to make sure that, because the malwares are mostly have the capability to connect with the external world. So it is always necessary to make sure there is no internet connectivity when you are testing a malware. And once you are done with malware analysis, revert the VM to its clean state for the next malware analysis session to avoid the residue from a previous malware execution corrupting the next one. So this is another advisory. If you are using a virtual machine, then there must be an option to take the snapshots of the VM. Snapshots are nothing but the, the storage of a specific state. When you're done with the malware analysis, you can simply revert to the previous snapshot. So that is what they are trying to explain here. So let's try to answer the questions they ask. Which team uses malware analysis to look for IOCs and hunt for a malware in a network? So the keyword is hunt. So the threat hunters they are trying to denote here. So that's what the answer. I hope threat hunt team. So the letters are matching. Yeah, that's the answer. So let's move on to the next one, the techniques of malware analysis. They are comparing the process of malware analysis with the process of solving puzzle. Actually, it is almost identical. Different tools and techniques need to be used to solve these pieces of puzzle, and it's a time-consuming process, of course. Joining those pieces gives us the complete picture of what malware is trying to do. So most of the time, you will have an executable file that is called the binary file, and it can be a Linux binary or Windows binary. If it's a Windows binary, then it must be a PE, portable executable file. The malicious, or it can be the malicious document file, or it's a network packet capture. Sometimes the portable executable is not, is the most prevalent type of file analyzed while performing malware analysis. Even if you refer the malware repositories out there, you will witness most of the executable files rather than the other kinds of files. To find different puzzle pieces, you will often use various tools, tricks, and shortcuts. These techniques can be grouped into following two categories. And here we are witnessing the process, two kinds of process in malware analysis. One is static analysis, and another one is dynamic analysis. Static analysis. When malware is analyzed without being executed, it is called static analysis. And this is the very important aspect of static analysis, because in static analysis you are going to analyze the malware source code and other properties of the malware. However, you are not triggering, you are not detonating the malware, and that is one of the important stuffs of static analysis. In this case, the different properties of PE file are analyzed without running it. Similarly, in the case of malicious document, exploring the document's properties without analyzing it will be considered static analysis. They are explaining, even you are analyzing a malicious document, you are not going to trigger the document. However, you will be analyzing it. The examples of static analysis include checking for strings in the malware, checking for PE header for the information related to different sections, or looking at the code using the disassembler. So these are the some of the process belongs to static analysis. We will look at some of these techniques later in this room. All right. Malwares often uses techniques to avoid static analysis. Some of these techniques use obfuscation, packing, or other means of hiding its properties. So these are the other techniques that is being used by the malware authors to hinder the malware analyst from analyzing the malware. To circumvent these techniques, we often use dynamic analysis. But let me explain what is dynamic analysis here. Malware faces a dilemma. It has to execute to fulfill its purpose, and no matter how much obfuscation is added to the code, it becomes easy target for detection once it runs. So in dynamic analysis, what they are doing, they are simply running the malware and they are recording all those activities that is being done while executing. So that is all about the dynamic analysis. Since it is being executed, we will be able to record all those background activities that is happening, that is made by the malware. And no matter there is an obfuscation or there is a packing and all, you will be able to execute that malware. So that is what the purpose of the malware. The static analysis might provide us with crucial information regarding malware, but sometimes that is not enough. We might need to run the malware in a controlled environment to observe what it does in these cases. Malware can often hide its properties to thwart static analysis. However, in most of these cases, dynamic analysis can prove fruitful. Dynamic analysis techniques include running the malware in VM. Yeah, this is what the technique that we were talking before. Whenever you are setting up the VM, once you infected the VM, you will be able to use those snapshot option to restore the previous state. So whenever you are performing dynamic analysis on the VM, you will be doing those snapshot restoration either in manual fashion with tools installed to monitor the malware's activity or in the form of sandboxes that perform these tasks automatically. We will learn about some of these techniques later in this room. Once we run the malware in a controlled environment, we can use our knowledge from the Windows forensics room to identify what exactly took place. So here we are using some of our forensics knowledge as well, because once the malware has executed in a controlled environment, you have to collect what are all the activities that happened in that environment, and for that you can perform some forensics either, or you can simply use some pre-initiated tools to collect the data. The advantage here is that since we control the environment, we can configure it to avoid the noise like activity from the legitimate users or Windows services. You are in the environment where the legitimate process and the legitimate activity is happening at the back end. And also the activities that is initiated by the malware also is going to take place. So in an isolated environment, you will be able to differentiate these two. The environment which is isolated will be running in a different place. It is an isolated environment, it will be running differently. So it will be easy for us to collect the data, collect the list of activities that is performed by the malware. Malware, however, often uses techniques to prevent an analyst from performing dynamic analysis. Yeah, malware authors are also making some hinder against the dynamic analysis. Since most dynamic analysis is performed in a controlled environment, most methods to bypass dynamic analysis include detecting the environment in which it is being run. So this is another one of the advanced and sophisticated feature of the malware. So what it is, what they are trying to convey, it is all about the malware's capability to detect the environment on which it is being run. For example, let me say a malware we are executing on a virtual environment, on a virtual machine, let's say on a virtual box. So what will happen whenever we are executing a malware on any Windows or Linux machine on a virtual box VM? The malware, first of all, it will check whether it is being executed on a virtual machine. It will check for the parameters that belongs to VMs. If it is suspect to be the virtual machine, or it gets the evidence of virtual machine, then it will terminate that execution, it will stop that execution. So that is the uh, property called VM detection, the sandbox evasion technique. So they will be discussing it. That's a sophisticated technique, so we will be seeing it in further uh, videos maybe. Therefore, these cases malware uses different benign code path if it identifies that it is being run in a controlled environment. Okay, moving to the next topic, advanced malware analysis. So this is one of the recommended and most wanted skills to have if you are a cyber defender. So let me say what it is. Advanced malware analysis techniques are used to analyze malware that evades basic static and dynamic analysis. For performing advanced malware analysis, disassemblers and debuggers are used. Let me give few examples. First of all, let me explain what is disassembler. If you are dealing with any executable, if you open it in a file, I mean, simple text file, you will be witnessing only some non-printable blob, non-printable characters. It is not a human readable language. So let me show that. Now in this path, I am having, yeah, an executable file called procmon. Actually, I downloaded this executable from Windows sysinternals library, and let me check its file type. Actually, this is 32-bit Windows executable made for Intel 80386 processor, an early processor, and it is for MS Windows. This is called the PE file, portable executable file, and I'm simply using a text editor to read this executable file. Let me show what we are going to see. When I open this executable, I'm simply seeing some random numbers. This is called bytes, machine language. It can be only understandable by the machine. So simply, if you take any executable, if you try to read it with a simple text editor, you will see this non-readable, not non-readable, machine language characters only. But if you use disassembler, you will be able to convert this machine language to some semi machine language. I mean, a disassembled language. Actually, that is the language, that is the stage between the high level and the low level language. So it is partially readable. It is readable by the human, and of course, you need to pay some time and some attention towards the disassembled code. Now I try to open the same executable in one of the disassemblers I'm having. I will show what we are going to see differently. I'm using the disassembler IDA 64-bit, IDA freeware, and this is one of the prominent disassemblers available. I'm trying to open it. Let's see what's going to happen. Now it is loading into this software. Yeah, now you can witness a code. Actually, it looks like some commands. So it is nothing but this is called disassembled code. Actually, this is the direct conversion from that machine language. But you need to know what are all these specific stuffs that given here and what are all these words denotes. So this is a different topic for different video. I just wanted to showcase how a disassembled code will look like. And if you see the debuggers, it is little bit different from the disassembler. In debugger, you will be able to see all those disassembled code. However, you will be doing some dynamic analysis in this debugger. I mean, you are going to run this the specific sample that you are up against by using this debuggers. And another beautiful stuff about in the debugger is you will be able to stop that execution anywhere you want, and you will be able to analyze that malware in a deep manner. So that is another excellent feature of debugger. So that is why we are saying the method of using these two tools is called advanced malware analysis, because it will take a lot of learning, it will take a lot of time, and also it will take a lot of effort. And disassemblers convert the malware's code from binary to assembly. Just now I have shown this, and so that the analyst can look at the instruction of the malware statically. So you will be able to witness each and every instruction that is given by the malware. And debuggers attach to a program and allow the analyst to monitor the instructions in malware while it is running. A debugger allows the analyst to stop and run the malware at different points to identify interesting pieces of information, while also providing an overview of memory and CPU of the system. Even the debuggers can give the information about the specific memory and the CPU. I mean the changes in the memory and CPU. If it is some denial of service malware, then obviously you need to note down this CPU and the memory utilization. And debuggers can also provide that. We will not cover the advanced malware analysis. Yeah, they are not going to cover the advanced malware analysis. However, it is just an overview. So by seeing this, you will be getting some idea, I hope. So let's try to answer these questions. Which technique is used for analyzing the malware without executing it? So this is the keyword. Without executing it, it is nothing but static analysis. And that is the answer. And the next question, which technique is used for analyzing malware by executing it and observing its behavior in a collected, controlled environment? And it is dynamic analysis. Yeah, that's the right answer. So moving to the next topic, basic of static analysis. Basic static analysis. When analyzing a new piece of malware, the first step is usually performing basic static analysis. So this is where you will be beginning the malware analysis. Basic static analysis can be considered sizing up the malware, trying to find its properties before diving deep into the analysis. So we are going, I mean, when you are doing the static analysis, the basic static analysis, you would be looking for the details about the file hash, the file properties, when the file was compiled, when the file was created. So you will be seeing, you will be looking at this kind of information, and that is the basic static analysis is all about. It provides us with an overview of what we are dealing with. Sometimes it might give us some critical information. For example, what API calls the malware is making, whether it is packed or not. However, other times it might only give us the information to help us size the malware up and give us an idea of the effort required to analyze it. So it will give you an idea what you have to do to analyze the malware further. So without further ado, let's see some of the techniques. Uh, they mentioned they mentioned a headline caution, and they gave a paragraph beneath that. So let's read it out. Pay your attention here. Although static analysis is performed without running the malware, it is highly recommended that you perform malware analysis in an isolated virtual machine. So it is always recommended to perform the static analysis as well in an isolated environment. You can create a clean snapshot of your virtual machine before performing any malware analysis. So it's a best practice actually. And revert it to start from a clean state again after every analysis. Do not perform malware analysis on a live machine not purpose built for malware analysis. And if you do, then the repercussions may be severe. For this room, we will be using the attached Remnux VM. So this VM is nothing but the Remnux Linux distribution exclusively made for malware analysis. Actually, it's a Ubuntu based Linux distribution, but they created it with some of the essential malware analysis tools. Accessing the attached VM. So this is just a step to access the virtual machine. So let's try to see the first one, examining the file type. We usually do use the file utility, right? Even before a while, when I was trying to find the file type of the Procmon executable, I was using this utility. So this utility is simply will give an insight about the file that we are dealing with. So let's see the example here. This screenshot this just they gathered from the same machine here, and they are just using this file utility against the sample called WannaCry. WannaCry, if you have no idea, then let me briefly explain. It's a notorious ransomware. It created a huge impact on the organizations across the globe 4 or 5 years back. And when they executed this, it gave an information about the file. So what sort of file it is, and what is the processor, and what is the compiler used to compile the file, and what operating system do we need to use. All right, so there is a folder named sample. So they just gave an exercise here. On the desktop of the attached VM, we will be using the samples present in that folder for our analysis. Above terminal shows file command being run in the WannaCry sample. Yeah, that is what they are trying to explain. So by seeing this outcome, we may get some insight about the file. It's a 32-bit executable for graphical. It's a graphical user interface file, and it is made for Intel processor 80386, and it's a 32-bit processor for Microsoft Windows. That's what they gave here in this paragraph. And the next command is string examining. So the strings is one of the handy utilities that you have in the Linux environment. It will simply enquire the printable, or in other word, human readable strings on any file. So that is all about the string command. If you need to understand, if you need to know further about the strings, then you are welcome to use the man page of given in the Linux environment. So let me simply open the man page of strings utility, and the description is print the sequences of printable characters in files. So that is the brief explanation. And the usage is similar, identical to file utility. After the strings keyword, you need to give the file name. So once you give like this, you can see all the human readable printable characters present in the specific file. And if I scroll down further, I can see the system calls here. I think these are the functions present in the Windows 32 API. Here we can see the strings command being run against the Wannacry sample. We will see the output starts with DOS stub. DOS stub is nothing but this specific message. This program cannot run in the DOS mode. So this is called DOS stub. If you witness the PE file, then you will see this DOS stub at the top, which is the next that says this program cannot be run in the DOS mode. The same thing. Some values don't make much sense and look like garbage, but you will also see useful output. For example, we can see that above some strings look like Windows API. Yeah, as I explained, we can see some functions here: close handle, get exit code process, terminate process, wait for single object, create process to create a process on the machine. So these are the Windows API calls. Similarly, we can see the text says inflate 113 copyright mark alter. The quick search. Let me search the same. To detect the inflate decompressor. Here they gave a specific link, zlib fingerprint. So what they are trying to say here, a quick search shows that it is a part of the zlib data compression library. Yeah, actually when we search this, it is giving the library that is involved. And a tip, sometimes the output of the strings command is too big. So this is just a recommendation. If you are a good user of Linux, then you need not to worry about this. You will get an idea. However, yeah, I'm just scrolling down further. They're using some other utility like more or less. They're just piping all the outcomes into this more or less utility, and they will get the shortened output. You can press the space bar and you can expand this. We can use the space key to scroll down the list of, yeah, that's what they give. Calculating hashes, and this is another important skill to have. And in Linux operating system, there is an utility MD5 sum and SHA1 sum and SHA256 sum. So these are the utilities to measure the file hashes. File hashes doesn't change unless you make even a small change in a file. The file hash is providing us a fixed size unique number that identifies the file. So this is very handy concept to identify, to spot, to differentiate each and every file. So this is very helpful whenever you are dealing with a malware. If you're dealing with the malware, you can witness so many samples, in a same category. But those samples must be those samples will be different because those hashes are different. So these hashes are very important to handle or to spot the different files. And a file hash can therefore be considered unique identifier for a file, and similar to social security numbers and the national identification number. They are just using these aspects to make us understand quick. Hashing is an important concept in a malware analysis. It can be used as an identifier for a specific malware. Yeah, even whenever you read any malware blog, they usually should have added the file hashes in there in the indicators of compromise, because each and every critical file hashes being used by people in cyber defense. As we will see later in this task, this identifier can then be shared with other analysts, yeah, as I said before. And these are the tools used to calculate the hashes, MD5 sum, and simply they are using this tool and the file type, it will give us the MD5 hash of the specific WannaCry file. So this is how you have to use. You can use it against any file. And if you are interested in learning more about the hashes, there is a separate room, and the room name is mal searching. But this is the topic for another video. So let's move on to the next one, AV scans and virus total. If you haven't explored this tool, this website virus total, then you must have to do, because these tools are used by wide range of cyber defenders or malware researchers, and even the cyber criminals do use this virus total to make sure their malware sample is not being detected by security vendors. If you see, there are three categories: file, URL, and search. You can either upload any file that you witness to find whether the file is malicious or not, or you can use a URL. If you have any suspicious URL, then you can type the URL here and start the analysis. The search, you can use URL, IP address, domain, sometimes file hash to spot the suspicious files. And if I scroll down further, they gave an example how to do that. They are simply typing the hash here, and they are just trying to find the nature of the file. And once they run the search, it is just giving the result. There are totally 66 security vendors. Out of 66, 61 vendors detected this specific file as malicious. And also here you can see the vendor name, and also you can see the type of software it is. And there is another tab. If you click the details tab, you can see the details about the sample. And if I scroll further, by clicking the behavior, you can simply see the basic network connectivity, domains, and other crucial informations from that file, and the relations. And of course, here you can see the domain and IP. Whether if the malware is contacting any other domain, then it will be recorded in this tab. And there is another tool called Joe Sandbox. So this screenshot denotes the excuse me, this is not a Joe sandbox. Actually, this virus total itself having another tab called community. If you click this community tab, then you will be able to witness the blogs and the post that related to the specific malware. And that is how this specific uh, information by Joe Security posted. And let me scroll down further. Perhaps it is very clear from the above screenshot that we are looking at the sample of WannaCry ransomware. Yeah, that was. And let's try to answer these questions. In the attached VM, there is a sample named Redline. In the desktop samples directory, what is the MD5 sample of, I'm sorry, what is the MD5 sum of this sample? So let's try to open the machine. I'm trying to open the machine. Now I close the split screen and running the same machine in a different window. I can see the folder called samples. I'm simply opening this folder and I can see the files called WannaCry, Redline, and some random name. I need to find the MD5 hash of the Redline file. And for that, I am opening the command line. From here, I am opening the desktop folder, samples folder, and from here I need to execute the command. And the command is MD5 sum against the file Redline. Now I found the MD5 hash of the specific file. Now all I need to do is paste the answer. Yeah. And what is the creation time of this sample? we need to find the creation time. We already copied the hash. It is in the clipboard, and I am using virus total once again. I'm directly opening the search bar and I am pasting the file hash here. I need to find the file creation time and date, right? That is what the question. Yeah. And we can witness it in the details tab. I'm using the virus total to get this information. And here we can see the details about the sample. It's a PE32 sample. And here I can see the creation time. So this is what we need. Yeah, by submitting this, finished this specific topic. Moving to the next task, the PE file header. The PE file header, if you haven't witnessed, if you haven't watched my one of my previous videos about the Windows system terminals, there I explained about this PE file header. You can also witness that, you can also watch that. But let me explain it once again. The PE file header contains the metadata about the portable executable file. This data can help us to find a lot of helpful information to help us in our analysis. We will go into detail about the PE header and the information it contains in the upcoming malware analysis module for the advanced path. However, some of the vital information found in the PE header is explained below. All right. Here you can see the section called imports and exports. If you witness this image, you can see the headings here: DOS header, DOS stub, .ndata, NT headers, file header, optional header, image section header, .text, .rdata, .data, .r resource. So here are the subtopics of the specific PE header. And imports and exports. What is imports and export? The PE file seldom contains all the code that needs to run on the systems on its own. So this line is a bit confusing. Let me explain clearly. If you take a PE file, then there must be some components. There must be essential components for that specific PE file to run, to execute. But in rare cases only, that specific PE file will contain all the required details within that file itself. Rest of the times, it will only depend on some external resources. And that's what they are trying to explain. Most of the time, it reuses code provided by the operating system. This is done to use less space and leverage the framework the operating system has laid to perform tasks instead of the reinventing the wheel. So this is just try to avoid the repeating process. So we need not to create the same code block repeatedly in every executable. You can create a piece of code and you can keep somewhere, and you can make all other malwares to refer that specific piece of code, so that you will be able to reduce the size of the malware and the execution time will be minimized. The imports are such functions that the PE file imports from outside to perform different tasks. So that is what the import function is all about. If you find any components under the imports topic, then you can assume that specific executable is referring some external resources. For example, if a developer wants to query Windows registry value, they will import the reg query value function provided by Microsoft instead of writing the code themselves. So what is this reg query value? Let's see that. Actually, we are in the Windows 32 API page. If you get into this Windows 32 API, you will be able to witness n number of functions that is supported by Windows 32 API. So these APIs are nothing but a gateway to interact with the Windows operating system. It's like an application programming interface. And if you see this reg query value w function, they can use this specific function, and this is the specific I mean, the specific header. So it retrieves the data associated with default and unnamed values specified in the registry. The data must be null terminating string. So the Microsoft itself offering a separate function for each and every activity. So the malware simply uses those functions rather than writing their own code to probe the Windows registry in this case. So it is understood that this function will be present on any Windows machine on which the developer's code is going to run. So it doesn't need to be included in the PE file itself. Yeah, that's what they are trying to convey. Similarly, any PE file export functions are exposed to other binaries that can use function instead of implementing it themselves. So what is export? We have seen import. We just learned what is import and why we are referring import, but the export, it is directly opposite. In any executable, if you are mentioning some functionalities under exports, then you can simply assume those functionalities we are simply giving to other executables. If you take the DLL file, dynamic link library file, those files are obviously being referred by many executable files. If you are analyzing any DLL file on any of the static analysis tool, under the export section, you will be able to see many functionalities, many functions. But the same thing, if you are witnessing the export section in any executable file, mostly you will not be seeing any functionalities beneath the export thing, because it is not providing any functionality to the other executable. Only the DLL file is providing the functionalities, because the DLL file is open to other executables. The exports are generally associated with dynamic link libraries. Yeah, that's what they are trying to explain here. Since most PE files use Windows API to perform bulk of their jobs, a PE file imports provides us with crucial information on what the PE file will do. It becomes evident that a PE file is importing the internet open function will communicate to the internet. So based on the functions you witness, you'll be able to get an insight about the functionality of the malware. For example, they gave a function internet open. If you witness this internet open through the strings, then you can assume that specific piece of software is establishing some internet connectivity. And if you witness URL download to file function, then you can assume that specific piece of software is downloading some file from the internet. And based on other functions, you can come to an idea. You can get an idea. The names of Windows APIs are generally intuitive and self-explanatory. So we already opened this Windows API page. So I'm just getting into this Windows API. So let me click this, and here I can see all those separate headings: user interface and desktop related functions given here, graphics and gaming related functions given here, audio and video related functions, networking and internet related functions given here. So what I'm doing, I'm trying to open the HTTP server API. So let me open this, and here I can see the header http.h. This is what the header you should be using. And the HTTP server API, obviously, it contains the lot of functions. Here you can see HTTP equal version, HTTP null ID, and if I scroll down further, I can see multiple functions of the specific library. HTTP cancel HTTP request, cancels the request actually, close the request queue. So for each and every operation, here you can witness the function, and that is the beauty of Windows API. Many PE files depends on the Windows 32 API. So if you are familiar with this Windows API, you need to have the skill to spot this Windows API calls. So that is very important skill to have as a malware analyst. And yeah, scrolling further, I can see another topic called sections. Another useful piece of information you would see while analyzing the malware is nothing but sections. And the PE file is divided into different sections. So here they gave all those sections. Although the sections in the PE file depends on the compiler and packer used to compile or pack the binary, the following are the most commonly seen sections in a PE file. So if you see the PE file, you will see these three sections mostly in common. The first one is dot text. What it is? This section generally contains the CPU instructions executed when the PE file is run. The section is marked as executable, and also the entry point of any executables will be witnessed in this dot text section only. And dot data, the second section. This section contains the global variables and other global data used by the PE file. And the next one is resource, RSRC. This section contains resources that are used by the PE file, for example, images, icon, and etc. All right. And analyzing the PE header using the PE check utility. Now we are in the Remnux distribution. In Remnux, there is an utility called PE check. You can use this PE check utility to analyze, examine the header of the PE file. So that is what they did here. They are just using the same PE-check utility against the same WannaCry binary. And if they check that they are getting the file hash here, apart from that, the sections present in the file .rdata, .rsrc, and here they can see a word called entropy. Actually, entropy is the state of improperness. If anything is improper in the executable, then it is measured in the entropy. So here they gave the recommended entropy level, and here they gave the present entropy level of the specific piece of malware. All right. And dump info, DOS header. They gave the information about the DOS header. And here you can see the image import descriptor. Here they are describing the section import. If you see the import, the first part is the DLL file. And beneath the DLL, here is the function. Create service. It is creating a service. It is opening a service, starting a service, closing a service handle, script release context, regarding registry create key, registry set value xa, registry query value. So it is also performing some changes in the registry. So by seeing this Windows API function, you will be able to get some idea about the behavior. I'm scrolling down further. Here we can see the information PS check has extracted from the PE file header WannaCry sample. So there are four sections as I said, and also the image import descriptor, and also the DLL file is being referred by that specific piece of malware. And we can see that PE check shows us a lot more information apart from what we discussed above. But now we are going to answer the questions. In the attached VM, there is a sample named redline. So we are going to take the sample with redline, and we are going to detect the entropy of the dot text section. So let's do the same. And the utility is PE check, and the file is redline. Okay, so it's a lengthy outcome. So I'm just routing everything to a file, and PE. I'm getting I'm giving the file name as PE header.txt. It's a text file, of course, and I'm using nano text editor to read the specific downloaded or the redirected outcome. Yeah, here I can see the dot text section is having the entropy value of 6.453919, and that must be our answer, I believe. Yes, that is. And the sample named redline has five sections: dot text, dot data, and dot resource. So these are the four sections. And what about the fifth one? So let's try to read that. Dot text, data, dot n data, dot resource. And we witnessed these four except the dot n data. And dot n data is the fifth one that we need to answer. Yeah, dot n data. From which all DLL file does the sample redline import registry open key xw function? So let's look for this function reg open key xw. If I scroll down further, Now we are in the section header. Yeah. Now we are in the import image descriptor, and here I can see reg open key xw. I think that is the function we are, yeah, reg open key xw. Exactly. And the DLL file is advapa32.dll, and that's the answer. And the next one, this is just an advisory. You can try this tool on your own. So they're just trying to, they just asked us to try the specific PE-tree tool against the file red line. So let's try. Why don't we try it? They also mentioned in the bracket this process might take some time. If it is time consuming, then we can skip and move ahead. PE tree against the red line tool. So it is time consuming. Let it load. I'll just mention it as completed. And moving to the next one, basic dynamic analysis. And let's see what we are having here. While basic static analysis provides us the useful information about the sample, most times we need to perform additional analysis to move further in our analysis procedure. One quick and dirty way to find more clues about malware's behavior is by performing basic dynamic analysis. Many of the properties of a malware sample can be hidden when it is not running. And however, when we perform dynamic analysis, we can lay these properties bare and learn more about the behavior of the sample. So here they justified why do we need dynamic analysis and caution. The same thing here, the same thing they gave. So whenever you are about to perform the dynamic analysis, do it on an isolated environment. Make sure the network is not connected, and every precautionary safety measures are taken before executing, because every piece of malware has the capability of infecting your machine and stealing your data. All right, moving to the next one, introduction to sandboxes. So they simply comparing the term sandbox with the military, and in malware analysis, sandbox is an isolated environment mimicking the actual target environment of a malware, where an analyst run a sample to learn more about it. Malware analysis sandboxes heavily rely on virtual machines, their ability to take screenshots and revert to a clean state when required. Actually, earlier I tried to run the redline file by using the PE-tree, but seems like it is throwing some error and also it is taking some time. So I am aborting this. Moving to the next topic, construction of a sandbox. Here they give the step-by-step procedure to construct a sandbox. If you are new to this malware analysis, then do set your own malware analysis sandbox. This is very, very important, and this would be your first step, the first stage of action. And for malware analysis, use sandboxes. Yeah, virtual machine. It is highly recommended to use the virtual machine mimicking the actual target environment of a malware sample. Ability to take the snapshot and reverse to the clean state. Make sure your virtual machine vendor is having the snapshot taking feature, and also you will be able to revert those snapshots to the previous state. And the next one is OS monitoring software, for example, Procmon, Process Explorer, RegShot. So these are the essential tools to run the dynamic analysis. The network monitoring tools also required, the tools like Wireshark and TCP dump, and the control over the network through dummy DNS server or web server. If any malware you are running running dynamically, then you must need to feed that specific malware whenever you are running in a dynamic environment. So what you can do, you can either run a dummy DNS server or a dummy web server, so that it will be feeding your malware fakely. And the next one, the very, very important one, a mechanism to move the analysis logs and malware samples in and out of the virtual machine. Since it is an isolated environment, you have to find a way to move your malware sample to your isolated environment, and make sure you are not using the shared directories in VM. Shared directory, actually, it is one of the features in the virtual machine where you will be able to share a specific folder between your host and guest system, and they are not recommending to use this shared directory because Malwares have the capability of navigating through this shared, propagating through this shared directory. All right. Now here they give in the next topic they gave some open source sandboxes. You can go and look for the Cuckoo sandbox. I will be adding this link in the video description so you can refer this. And the Cave sandbox, another sandbox utility. And they gave the drawbacks here. The Cuckoo utility, the Cuckoo sandbox doesn't have the Python 3 support. However, the Cave sandbox is supporting it. And here they gave some of the online sandboxes, any.run, integer, hybrid analysis, online Cape sandbox, online Cuckoo sandbox, and you can also add the Joe sandbox here as one of the online sandboxes. Though online sandboxes provide, I'll also add the links belongs to these, links of these online sandboxes in the description. Though online sandboxes provide useful utility, it is best not to submit the sample online unless you are unsure of what you are doing. If you are in a organization, you are not sure which sample, which is the software you are dealing with, then you should not be uploading the file that you are unsure of on the online platforms because it is considered as the data leak. So what you can do, better you can use the isolated environment that is present in your organization in offline. And and also what you can do, you can just collect the samples hash and you can search that specific hash on the internet. You might get the same sample from the internet. And analyzing samples using hybrid analysis. So here they gave the interface, where you would be analyzing the sample, and also the result. Once the analysis is done, the result would be like this. They gave the date, the file type, and the analysis summary. If you click this and get into this specific entry, you will be able to see the detailed, extensive view of the analysis. Yeah, this is what they gave here. You can also see the mitrate techniques detection for each sample. What sort of technique it is incorporated. What sort of techniques incorporated in that malware. That can be witnessed here. And moving to the hybrid analysis, it is now moving further. I can see various fruitful information here. And the network analysis, you can see the contacted host to which public IPs the specific malware sample contacted, and also the extracted strings given here. All right. And let me try to answer the questions asked here. Check the hash of the sample of the red line on hybrid analysis. Check out the report generated on 14th March 2022. Check the incident response section of the report. How many domains were contacted by the sample? So let's try to do that. We are again using the red line sample here. So let's try to find the hash value of the red line sample. I'm trying to find the SHA-256 sum hash this time, and the red lines against the red line. So this is the SHA-256 hash of the red line malware, and I'm just searching hybrid analysis, and this is the sandbox. I'm simply pasting the file. No, I should not paste here actually. I should go to the file section tab, the report search tab, I guess. Yeah, report search tab, and I am just pasting the file hash searching, and this is what they asked. The sample, the analysis that ran on March 14th. So this is what I need to look, and they are asking about the domains, the number of domains, the specific sample communicated, and let's see that 14th of March, how many domains were contacted by the sample, and if you see here, network behavior contacts 8 domains and 8 hosts. So that is the answer, 8. And in the report mentioned above, a text file is created by the sample. What is the name of the text file? So the text file they are asking. So this specific malware also creating a text file. So they are asking the name of the text file. Right? The text file extension is .txt. So let's look for the .txt extension, I'm just searching in this page. So here I can see the file name. The file name is same. So this could be the answer. Yeah, here it is. So this is the file that we are witnessing. I mean that we need, and that's the answer. Moving to the next one, anti-analysis technique. As I said before, malware authors do often enhance their malwares and they introduce some new sophisticated techniques which prevents the malware analysts from analyzing that malware. So let's see what are all the techniques involved. While the security researchers are devising techniques and tools to analyze the malware authors are working on rendering these tools and techniques ineffective. We found a great deal information in previous tasks about the malware we analyzed. However, there are ways malware authors can make up our life difficult. Below are some of the techniques used by malware authors to do the same. Packing and obfuscation. The first technique used by malware authors to dodge the security systems and also the malware researchers from researching. And malware authors often use packing and obfuscation to make analyst life difficult. A packer obfuscate, compress, encrypts the content of the malware. These techniques makes it difficult to analyze malware statically. Specifically, a packed malware will not show important information when you are running it on the tools like PE check. So here is the demo. They are just using another sample with random text, and they are using the string utility. They're just trying to find the strings, valid strings of the file, but they are only seeing the nonsense blob here because that specific malware is packed. We will notice that this sample contains mainly garbage strings. Yeah, and moving to the next one, we are just using the same file against the tool PE check, and we don't see the proper info here. Here you can see the parsing warning. This is the message we are getting. This might indicate a packed executable. Yeah, as suspected, it impacts the malware analysis job. So we see that the executable has characteristics typical of packed executable as per the PE check. We will notice that there is no text section in this sample and the other sections have executable permission. So yeah, this one we should have noticed. Here I don't see the dot text section, and which shows that these sections contain executable instructions and will be populated with executable instruction during the execution. We will also see that this sample doesn't have many imports that might show us its functionality as we saw with previous sample. For analysis of packed executables, the first step is generally to unpack the sample. This is an advanced topic that we will be covering in the upcoming rooms. Sandbox evasion. So this is the topic that I gave a brief intro before. So what they are denoting, what is all about the sandbox evasion. So these are the techniques. Long sleep calls. The malware authors may build the malware to sleep for some time before running its execution. So whenever you are using such malwares in sandboxes, whenever, I mean, especially you are trying to analyze it dynamically, since it is calling the sleep function, it won't be executing for a long time, so you will not be getting the precise result. And the user activity detection, it also look for the user activity on the specific environment on which it is running. Let's say the browser activity. If it is a typical machine, then there must be some browser activity and some file system activity. So malwares are often look such activities before executing. So if any suspicious environment, no such activities, no browser activity, no file activity, then eventually it stops its execution. And next concept is footprinting user activity. Some malware checks for the files activity. Yeah, that's what they're trying to say. The MS Office history, internet browsing history, things. And the user activity detection, one more point I left out. Sometimes the malware detects the mouse movement also. So whether there is a mouse movement, whether there is a keyboard access, so the malware can look these kind of stuffs as well. That is why we are calling this sandbox evasion techniques as one of the sophisticated, one of the advanced techniques to evade the detection and detecting VMs. As I told before, when I was telling about the sandbox evasion briefly, malwares are often, I mean, some malwares often check on which platform, on which environment it is running, on VM or not. If it is VM, there must be some separate, there must be some exclusive parameters present, and it usually look for that. They give the explanation here. Some drivers installed in VM being run on VMware or virtual box. So if the machine is VM, the malware will always look for such drivers, and once it finds it's a VM, it will terminate that execution. And yeah, so let's try to answer the questions. Which of the techniques discussed above is used to bypass the static analysis? So let's see the hint. String search is static analysis, and the technique is packing or obfuscation. But here, the number of letters, by seeing the number of letters, I presume it is packing, and that's the answer. And which technique discussed above is used to time out the sandbox? And what it is nothing but long sleep calls, because it won't perform any activity until certain time. So there will be some timeout. The purpose of this technique is to time out the sandbox. It is nothing but long sleep calls. And that must be the answer. Yes, that is. And moving to the last part, the final part, conclusion. Conclusion, there is nothing much. They only gave the concept that we have discussed earlier, the static and dynamic analysis of the malware, finding strings, calculating hashes, running AV scans on the malware, introduction to the PE header, how to get the information from the PE header, sandboxing and the different online sandboxes that we may use, how malwares evade the techniques we just discussed. So we will be working on malware. Yeah. So what they committed is they will be working on the malware analysis further, and they will be coming up with some advanced malware analysis tools. So we shall wait for that. But for now, it is time to complete this specific task. Yeah, we have successfully did this. We have learned what is malware analysis, how someone can begin the malware analysis, what you must know about malware analysis as a beginner. Yes, this is what I exactly wanted to convey. I hope some of you will get benefited through this video. I hope you really enjoyed this. If you really did, hit the like button. Consider subscribing my channel. If you have any other opinion, put it in the comment section. I'll be reading those, and I'll be responding to your valid questions. I'll catch you next time with another exciting video. Until then, I'm signing off. Cheers, and love you guys.